on a tech expedition with Kubernetes magicians. Add some spring to the mission. It's your crowd. The cloud made this crew. Cloud famous too. Cloud native crew.
I don't know why. I just dig it.
There we are.
I'm still digging the music.
What's that?
I'm still digging the music. It's only been 3 weeks, whatever. But yeah, that's still makes your feet move a little bit. I don't know.
Yeah, I definitely sing it in the shower.
Well, okay.
And other places.
Maybe I need to listen to something else then. I don't know. Like, I haven't gotten to the point where I'm in the shower singing it, but I could be. Okay,
You
that's
could be.
fair. It's yeah,
It could be.
It
happens very quickly, Josh. Be careful.
Yeah. Next thing you know, you're
Sneaks
singing
up
your own
on
theme
you.
song.
Yeah.
Did you ever the Java Posse? We've talked about this before. They had a really catchy theme song. The Java, jing, jing, jing. Anybody remember that? That was like endlessly catchy, and I couldn't get it out of my head, and I still can't for years. That's the thing I sometimes find myself humming in the middle of random interludes.
Yeah, well, that was definitely an inspiration for us getting a song. So
Yeah, well,
hats off to them.
that and MASH, right? They had a theme song. Not that this has anything to do with the war or anything like that, but if you're gonna have a theme song, it should be like MASH.
Yeah, you forget most things, but you don't forget theme songs.
Yeah.
So Deshaun is on vacation. He's on a beach somewhere.
How dare he?
Him.
Have fun. It's only like perfect weather and beautiful long days. Why would he be not in front of a computer?
Right.
Yeah, the CAD, computer automated,
Drone.
designer. I don't know. Yeah, I don't know. Yeah, Deshaun. Oh yeah. Oh, how did I miss that? I rocked right in and then away from that. That was that's.
So what's
quality of the show has gone down precipitously without him. I can tell.
Yeah.
He wouldn't have let me make that. There would have been a buzzer and some electricity. He wouldn't have let me make that joke.
That's right.
Yeah, that's fair. Anyway, good to see you. At least
Likewise.
you didn't abandon the ship.
I'm here and I'm excited for today's episode. I think so. We have first of all, I'm super excited about Ben Hale being here.
Oh yeah, love that guy.
I know you saw him this week.
Yeah.
Or recently, the last couple of weeks. And I got to chat with him just to prepare for this, and it's always it's this abundance, like this so much knowledge. It's just like I try to take in the little bits from everything he says and try to absorb as much as possible. But it's always like a pleasure and a privilege. So I'm excited that he's here to join us.
Yeah, I love that too. You don't often get good things in life, but this is one of those rare exceptions.
Yeah.
When I first met him, I thought he was Rob Harrop, and it's not great. So hopefully things have gotten better. I thought he was. So there's a at the time Ben was living in the UK, and I'd only briefly seen Rob Harrop when I first joined the company. Right, I had seen him every now and then at some shows, but I don't think I'd ever had the privilege of really interacting with Ben all that much, even though he had been there. Certainly, he was around. So I mistook him for the other, person who lives in the UK that kind of had that same frame or whatever at the time. They've diverged. They're both equally amazing and handsome these days in different ways. It's just at the time my little pea brain was like, oh, that's the same person, even though
it was not.
It's not. It's definitely not. And then he was great. He was like, yeah, I'll never forget. He's like, I asked him, are you I was trying to figure it out, and he's like, hello, governor, or something like that. Just got a good laugh.
When did you meet him? How long ago was that?
I'm sure he would say too long. No, I don't know. It was God, it couldn't have been 2011. I mean, 2010. It wasn't 20. It was probably 2010 actually. Spring one. He was probably at the spring one in 2010. So that's the first spring one I did as a member of the team, and it's just been downhill. Been downhill from since then for him.
Interesting. You joined the spring. I feel like we should do an episode where like we interview you, because I feel like your history of how you got into this field and how you joined the spring team, and just like the sort of like the passion and the personal interest that led you to want to communicate all of these ideas and thoughts and guidance. Like, I think that's really fascinating. So I'm gonna have you as a guest sometime.
I appreciate that, but the secret to my success is very, very, very easy. Just ride other people's coattails. If you can find yourself a Ben Hale, then you're going to be okay.
We're going to be riding Ben's coattails today for sure.
Yeah, I'm all about that. It's worked for me for 12 years. It'll work today as well. And I appreciate that.
Yeah. We have Whitney says, hello, friends. We have OG555. Powered by Tone says, heyo. Ready, set, day.
Heyo.
Welcome, everybody. Thanks for joining. We're excited
to
hear it here.
I hear it in the Ed McMahon, heyo, like that.
Heyo.
That voice.
So I'll just lay out kind of what we're thinking for today's episode. We don't have to get right into it, but just so folks know what's coming, because this is our third episode, and so
I can't believe we made it.
We made it, yeah. That's a sign of success. Third's the charm.
Yeah, and the last two weren't. Nobody died or anything, so it was okay. I'm pretty actually pleased that we got this far. Yeah.
Yeah. And so for anyone who's new, the structure of the show is we have different kinds of segments. So we have a segment where we focus on plain Kubernetes. That one's called Kubernetes. We have a segment where we focus on things Tanzu, so sort of the umbrella of products. There's commercial, there's open source, all kinds of products that VMware brings to the table for making your life with Kubernetes more awesome. That is Canz Tanzu. We have a section, of course, we've got Josh and Deshaun, so we've got to get as much Spring into the agenda as possible.
And Cora.
Well, I used to. I've forgotten,
No, you didn't. Oh,
I feel like Kubernetes is now 99% of my life.
That doesn't mean it's like riding a bicycle that delivers to production, right? It's you're too modest.
It's it's like I have to say, even though I haven't been working with Spring a lot, probably in the last year or so, one of the things that I love about working at VMware, or what was pivotal before, is just the opportunity to work alongside the Spring team, and they're so accessible, and it's just sort of amazing to have them at a Slack away. I mean, they make themselves accessible to the community, so maybe that's no different, but it's made me much more aware of sort of the team and how it operates and who's a part of it, and the history of it. So that's been really nice for me. So
I agree. And by the way, I was just thinking about this today, to that point, because they are open, warm, and friendly, and dare I say cuddly, but that's despite the fact that they're I think it's still true. I don't know, but it used to certainly be true that the Spring group was within the larger organization the most geographically distributed part of the organization, right? And so when the plague descended upon us a few foul years ago, nothing changed. We were just already set up for that workflow. We were already distributed and decentralized, and so the fact that they've gotten being personable and helpful and friendly and approachable down to such a T, and to do that over the sterile, texts of a Slack or a Twitter, yeah, amazing.
Yeah, that's true. I mean, it's funny because a lot of I feel like some modern companies get a lot of attention for being fully remote, and the truth is that the Spring team has been doing that for quite a long time. Yeah,
exactly. That's a secret I would love to figure out, and maybe there's no single oracle that said here's how we will be distributed. It's sort of a mind think, a group think that we all just sort of pulled together, and it was a lot of that was there even before I joined, obviously. So we should have that. That'd be an interesting episode. That's an episode I'd love to figure out.
How the Spring team works remotely in general.
Yeah,
we could have several of the Spring team members here sometime.
Yeah, it's a meta show. I don't normally do meta shows, but this would be one that I think would be particularly apt in the era of the pandemic.
We can do it. So Spring It On is our segment where we talk about all things spring. And then we've got our segment for special guests. So that's where we'll bring in Ben today. That's Tanzu Players.
Yes.
And then our last segment, which we do, is called Evolution or Revolution, where we pick a concept, pick a technology, pick some kind of change, and debate about whether it's an evolution or a revolution. Ponder, maybe more than debate. So on the docket for today, we don't do all of them every time because we go way too long. But today we're going to do a segment on Tanzu, or is it Tanzu? Maybe Ben can tell us how to pronounce it properly.
Tomato, Tanzu.
One of the two.
Yeah. Let's just call the whole thing off.
Let's call. Okay. All right. Well, that was it, everybody.
Yeah. That song.
And then we'll talk to Ben, and then we'll keep Ben on for evolution or revolution, and pick something that would be near and dear to his heart.
Yeah, please. When do we do the news?
We do it now.
We're doing it now.
But first, the news.
We'll do it live. Yeah. Okay.
Okay.
Good. Yeah. What's new with you?
Oh, well, so I'm going to KubeCon. KubeCon is in about 10 days in Valencia, Spain. So if anybody's going, I will be there. Find me at the VMware booth. I'll be helping people through hands-on exercises on Tanzu. So if you're interested in that, come on over and say hello. And if you're not going to be there in person, but you still want to listen in on the different talks, you can register. The keynotes are free, and the virtual, I guess, spaces are free. And it's $75 if you want an all-access virtual pass. So
wait, $75, and you get access to everything save for the COVID?
Yes.
That's a good
Stay
deal.
on airfare.
I wouldn't have paid much extra for the COVID. I'm actually just very happy I want that content. $75. That's
$75. Yeah.
Wow.
That's what the website says. Yeah.
Yeah. That's nice. And that's in Spain, so it's 75 euros or dollars?
I think the website says dollars. I can quickly pull it up, but
that's great. I'll take it. Yeah. Hey, good stuff.
Yeah, I can throw the link in here. So this is the link to, whoops.
Oh, Whitney says she'll see you there. I'm so happy that.
Yes, Whitney will be there.
Are you going to be, surely you're going to be at Spring I/O?
I'm not, I don't have that on my schedule. When and where is that?
Spain in like May 20 something. So we might actually, if you're in Barcelona, in or near Barcelona.
Oh, are you serious?
We should grab a tea and then lots of like wine, sangria and stuff, Whitney says she won't be at Spring I/O.
But she will be in Spain. Okay, let's figure that out. So
yeah, like we could do an episode. We could do one of these episodes in situ, in place, in some beautiful secluded, studio
May
in
26,
Spain.
27. You know what?
Yeah.
I won't be there anymore. I'd have to figure out if I could stay longer, but I won't. I'm flying back on the 23rd.
I arrive for reasons in Spain on the, let's say, 18th. So
okay. Then yes, I will see you there.
yes, let's find a way. I mean, it's not how far. I mean, I don't know how far the difference.
No,
I don't know what the difference is.
I will be in Barcelona from the 20th to the 23rd, so we'll make it happen.
Yes,
Yeah.
It's gonna be so good.
Okay. Isn't this fun? Everybody watching us make travel plans.
Yeah, this
what
is
we're going for.
riveting.
Anybody
It feels
listening,
so
come meet
riveting.
us in Barcelona the weekend of the 20th to the 23rd.
Yeah, well, I'm also going to Ibiza, which is, I got to figure out when that is, just to make sure we're not somehow in the same place, but not in the same place,
The best opening line, in my opinion, of a movie was the movie About a Boy, where Hugh, what's his name? Hugh something.
Grant.
Hugh Grant opens the movie by saying, "They say every man is an island. I am Ibiza."
Okay, that's a great line. I will remember that. I'm gonna tell it to my partner, and I'm not gonna give you credit. You just think I'm cool. She'll just think I'm cool and she won't know the truth.
You don't have to give Hugh
Okay.
Grant credit either. Matt
Ah.
Rabel will be there.
Matt,
Awesome.
Rabel's there. Oh, Rabel, what's up, man? Dan's on the,
Awesome.
on the line.
Do
We
an
got,
episode in Toronto, says Dan. Yeah,
yeah,
all these
Dan
things.
Vega, yeah.
Yeah.
Like, I would love to do live recordings of this because this is way more fun live. That's why, you know.
Oh yeah.
Not, I mean, it's not more fun for me. I'm saying it's more fun if there's like an audience.
Oh, with an audience.
You know,
oh yeah.
Yeah, the energy I think is cool for people who are in audiences watching this kind of thing, as opposed to just being online streaming.
Yeah.
But you can't wear your pajamas to the live taping. So
Oh, you can. And we will.
okay, I take it back. What do I know?
So what else do we have for news? So we've got 2 conferences coming up in Spain.
Yeah, I'm gonna be on the road. I kick off on Monday. I'm going off to London, which is a place that you can go if you want to be in the UK, and I'll be doing DevOps UK. That's a fun show.
Nice.
Then it's off to I'm talking to people, and then it's off to Spain, and then Portugal for J Nation, and then there's the Spring One Tour Toronto event, and then I'll be in Berlin for We Are Developers.
Wow.
This thing there, and raining. It goes from raining to pouring, right? I have done one live show, and it was in this country since the plague, and now I've got more than one, less than a billion. That's fun. What else? This week was pretty crazy. Like, there's been some good stuff here, including a whole thread I wanted to talk to Ben about. That's we can
All right.
table that until he gets here. We released Spring Tool Suite 4.1, 4.1. We did JDConf. I just spoke at JDConf, the big old Microsoft online thing. That was a whole to-do. That was a lot of fun for people who are using Azure Spring Cloud and wanted to take up more. Those videos will be online, no doubt. So I hope people will find those. What else? I mean, it's just been. I had Simon Ritter on the podcast, Java champion, fellow Java champion, and neat, Java luminary type. He was just on the podcast. Greg Turnquist had a really great blog titled "Ever Wanted to Rewrite a Query in Spring Data JPA?" Right, and it just talks about some of the nice new features in Spring Data that will just make it easier to rework certain queries and use something called a query rewriter, which is it's easier spelled than said, I suppose. But that's cool. There's just cool stuff. There's a lot of cool stuff in the last week for people to check out. Spring Cloud 2021.0.2. So for those of you paying attention, I said 2021, not 2022. So that's I suppose it's a maintenance release for something from last year. Just a lot of good stuff. I don't know if people are paying attention. Oh, and Spring Boot's coming. Spring Boot 2.7. It's coming. It's not here yet, but it's imminent. You go to start.spring.io, get your bits, try it out. Things are going to be spicy. Yeah.
Exciting.
So.
Good stuff.
Good stuff. Oh, and there's a blog. They got rid of Docker Shim, right? Docker Shim got kicked out of Kubernetes. So Casgrove had a post on why Docker Shim has been removed as of Kubernetes 1.24. I think it's kind of an interesting read. There's a lot of historical context and the discussion around container runtime interface and good stuff there. So I don't know. There's got to be other stuff, surely.
I think Istio applied to join the CNCF was another one.
Cool.
Oh
yeah.
Good stuff.
Yeah, that's awesome.
Good stuff happening. Dan says Spring for GraphQL 1.0 is coming this month.
Yeah, that'll be folded into Spring Boot, and so it, before we can have Spring Boot, we need Spring for GraphQL. I'm excited about that.
Yeah.
They just released new GraphQL. I think we talked about it on the last one. They just released RSocket support, so you can do GraphQL on top of RSocket, which is neat. Two of my favorite things.
Powerful.
Yeah, and actually that's also two. It's a one Facebook technology being transported on top of another Facebook technology, being made usable and awesome by Spring, which is, just feels right.
We should do a segment on RSocket.
Yes, or 12. I mean, I'm with you. That's, and Ben could talk to us about that. Actually, he's got some. He'll have a thing or two to say about
I
or
feel we
something.
could be
I
here
expect.
until midnight once Ben gets
Yeah.
back.
Yeah.
So speaking of that, should we move it along a little bit so that we can get Ben on? The faster we get Ben on, the better. I would think. So we have. Should I go on to the Canzu Tanzu or Kanzu Tanzu segment?
Yeah, please.
All right.
Yes. I'm
All
gonna
right,
step
so-
away and make a
No, you
drink.
guys can actually. I mean, I don't think you have to step. Well, last time we stepped away, and I thought you looked kind of lonely up there. I don't know, but you guys. I mean, we could even bring. You know, you guys can come in, or if Ben wants to come in, and we can chat
Yeah.
about. Yeah.
You bring him in. It's the 5th of May, or Cinco de Mayo here in the States, and as far as I know, it's not really a big thing in Mexico. I think it's more of a big thing here. Is that fair? I don't know. I mean, but any chance I can get to drink tequila, I'll take it. So
Okay.
while you do amazing things,
I'll do this then, and you go drink
Yeah.
tequila. Just
I'll make a drink.
come back, you know, sober enough that you can still hold a conversation with Ben, and then, but that's that, you know, no less.
Did you see you saw that first Avengers movie where they were like through the whole movie they were asking the Hulk, like, has he managed to get his anger management problems under control, basically? Has he managed to not become the Hulk, to not wig out and become a murder monster? And then at some point he finally explains how he's done it, because what they explained was he only does that when he gets angry, right? And so finally at the end of it, like right before he just lands this gigantic wallop on this monster that was coming at him, he explains that the way he managed to solve this problem of being like moved into this bad position where he's like the murder monster without his consent is he's always angry, right? And so I have that same kind of approach to this. I'm always incoherent and useless, and so the drink doesn't make a difference. So I'll be right back.
All right then. Okay. So in the meantime, let me move Josh off screen, and I will share my screen. Oh, so first of all, I have to do the proper way of switching this over, which is to say we're going to Canzu Tanzu, and that might be added. We have to add music to those, I think. But anyway, so okay. Oh, can I switch this? I'm looking to the wrong side. Anyway, all right. I'll figure this out for next time, but just bear with me right now. So what I want to show you is so Tanzu, there's a lot of different parts to Tanzu, but it's a commercial product set based on open source technology. And the open source set, the term for the open source is Tanzu Community Edition, sort of this umbrella term for a lot of open source projects that work together very well and provide a better developer experience, a better operator experience. And so what I wanted to demo today, let me just make this a bit bigger so you can see, is using Tanzu Community Edition with a particular package, because it provides packages. So it provides a curated set of packages that make managing, that make it easier to turn your Kubernetes cluster into something actually that's more of a developer-friendly platform. And so one of these is called Application Toolkit. And Application Toolkit is actually a meta package that installs various packages that will work together. So this is the easiest way to get to a point where you've provisioned a cluster and you can just submit, as a developer, just submit a workload and have it go through basically a CI/CD workflow, what we call a supply chain, from source code to a running application in your cluster. So that's what I want to show you today. And I wanted to take some time to explain kind of what's happening under the covers. So this is just to show you the Tanzu Community Edition.io is the website for Tanzu Community Edition. So you can come here and check it out, download the CLI, which allows you to provision clusters, go to the documentation. And here you can see that there are, getting started references. So you can either deploy this is what we're gonna use today, just a single cluster. It's called an unmanaged cluster. They can be run on different kinds of providers. I will be using one that's just installed locally on my Docker machine, but you could also use Tanzu Community Edition to deploy a management cluster that then provisions other workload clusters. So if you're trying to work at scale and provide Kubernetes for an enterprise or for many teams, then that's the route you probably want to go. And so there's instructions here on how to do all of that. And then there's this list of curated packages, and you can see here, there's documentation for each of these packages. And so these are things that they're not all, they're just ecosystem technologies. This is not all VMware technology, but it's a curated list. It's kind of overwhelming to go to the CNCF chart and try to figure out what are the things that you're going to put together to make your Kubernetes cluster more developer friendly. So here is a curated list of not only like a selection of tools, but also a packaging of these tools to make it easier to install them. And so in particular, the newest one called App Toolkit. So the documentation right now only shows version 0.1.0, which you can see is experimental. I've actually gone ahead and installed the release candidate for 0.2.0, but whichever one you use, the experience is similar. And so you can see that in this one is actually a meta package that installs several of these other packages listed on the left. So we'll come back to exactly what this is doing, but the steps that I'm going to follow are more or less what you would do if you were following this documentation, except I'm one version ahead, but that's a detail. So that's where you would go to read more about what we're going to talk about. And let me just check the chat. Good morning, Ashish. Nice to see you again. We won't tell Ben. Don't worry, Dan, that you interviewed with Ben. that you were intimidated. Well, I'm intimidated every time I talk to Ben, but don't tell him that either. That'll be our secret, Dan. Okay. So this is the way, I find that this, products nowadays, especially products that are relatively new, as is Tanzu Community Edition, change a lot. So I've decided to show the version that I'm using on every demo so that there's some kind of placeholder to provide a reference. So this is version 0.12.0, release candidate 2. And so, as I mentioned, it's all about the packages, right? You can provision a cluster, which I did using Tanzu, which is a single command, which I think I saved here to show you. This is the command that I used to provision the cluster. So the first thing that I did was install this CLI called Tanzu, and then I ran this command to create a single unmanaged cluster right here on my Docker and expose a couple of ports, and that just kind of shows you this output. And by the end of that, it says cluster created with a nice little green check mark. And then if you do that, then you've got a bunch of packages available to you. Now, it doesn't mean that those packages are installed. It just means that they're there if you want to install them, right? This is just a cluster, so you can do whatever you want with it. So this shouldn't be quite so slow. Okay, there we go. So these are the packages that are available. Same ones that were listed in the documentation. And so I want to install this one in particular, which will install a total of about 6 of the others. So again, I already did that because otherwise it would be too slow for this demo. And here is the command that I ran to do that. So I basically said Tanzu package install, and I name it App Toolkit. And then I give it the name of the package, which is App Toolkit Community Tanzu VMware.com. I'm installing version 0.2.0, and there's some configuration parameters that you need to provide. They're fairly straightforward. In fact, these are the parameters. This is the configuration file with actual values instead of environment variables, but it's pretty straightforward. Some contour configuration to use cluster IP, some knative serving configuration to assign a URL, and then some configuration for KPAC to be able to connect to a registry to publish images, and for cartographer also to be able to publish images to that same registry. So pretty simple. And so then after all of that is installed, you can also list out the packages installed versus those that are available, right? So the last thing I showed you was the ones that are available, and this is installed. So a little hard to read because of the formatting here, but so you can see App Toolkit, Cartographer. We have this Cartographer catalog. I can get you a better view of this. Okay, so these are the packages that we've installed. So what can we do with this? One of the interesting things that was added in version 0.20 of App Toolkit is this Cartographer catalog, which Cartographer is basically a tool that enables you to choreograph activity between different Kubernetes resources. So if we're thinking about, if I'm a developer and I have an application and I want to deploy it to the cluster in an automated, repeatable way, then the first thing I need is some process that's going to look at my Git repo, because I just want to do a Git commit, and I want some automated process to notice every time I do a Git commit. Flux CD Source Controller is an ecosystem tool that does exactly that. So we're going to be using Flux CD for that. After this process notices that I have made a Git commit, then I want that my automated toolchain to build an image, right? So KPack is a product that uses cloud native build packs to build and publish images. So again, part of the ecosystem, we're using that. And then finally, once KPack is done and I have an image built from my source code, then I just need to configure some YAML and apply that to Kubernetes so that I have a running application. And I could just use a deployment and a service and an ingress or a proxy or something very basic in Kubernetes, but that doesn't really give you a lot of functionality for your running application. Where I would prefer a product that gives me automatic scaling or management of versions or management of traffic. And that is what Knative Serving does. So we are going to use Knative Serving to actually run our application. And then these three products are, three products made by three different companies. These products don't talk to each other. They don't know about each other. So it's not like Flux CD notices a commit and is going to tell KPack about it, right? Or nor does KPack know to inquire with Flux CD to see if Flux CD has done anything. These are completely independent things running in Kubernetes. So we need a layer on top that is aware of them and that can notice when Flux CD has a new commit and trigger KPack to build a new image, and then notice when KPack has built a new image and trigger Knative to redeploy that image. So that is what Cartographer is for. And the nice thing about this particular version of Toolkit, of Application Toolkit, is that it includes this Cartographer catalog. So it includes basically this basic workflow that you can use as a default. You can always build other workflows, build on top of this workflow, but it's nice that there is one there because you can basically immediately after installation deploy a workload. So as a developer, I would run the couple of commands that I showed you earlier, create a cluster, install App Toolkit, and then I can immediately say Tanzu apps workload create. I give it a name, my first workload. I point to my source code repository. I give it the URL and the branch, right? And then I give it a type because the sample supply chain that is included in the Cartographer catalog has a type, and we need that to match, because if you had many different workloads, you need some label to match a selector in the particular supply chain you want to utilize. And you can give it some more information, and basically you're good to go. So we'll watch this. So the other nice thing that this does is it all of the pods that get created in this process, it automatically collects the logs for them and it streams them to your console. So I don't have to go digging for what pod is doing what or what's going on. I just have to give it a moment. And the thing that takes the longest here really is building the image. And so you can see here, first of all, you can see that it's given me the equivalent configuration of my imperative command with YAML. So if I wanted to do this in a declarative fashion, I could take this configuration and use that to create my workloads in the future. And now, so the first thing that would have happened is that a Flux resource would have been created to monitor my Git repository, and it would have noticed that there was a Git commit to build. The first time you do it, it just takes the latest Git commit. And that would trigger KPAC to build the image. And so when KPAC builds an image, it does it in a pod. So we see this output here. So this is coming from, you can see all of these are stages of the build. And we'll just give it a second to finish. You can see that, we didn't have to tell KPAC what kind of application it was, but we can tell from the output that it was a Java application. So we'll just, it's getting the JDK right now. And so the other nice thing about this, building a workflow in this way, is that you really have the opportunity to choose for every step of your workflow sort of the best in breed options in the ecosystem, right? And so there's different ways you could build an image. If you're using Dockerfile today, then you might be interested in exploring maybe using Canico. So you could use a combination of Tecton, which is a pipelining tool, to call a script or to call a task that would use Canico and that would run your Dockerfile. There's different ways of approaching building images, but KPAC is a much more uniform way to do it across your organization, and it has features for efficiency, for security, for swapping out operating systems so that you can easily fix CVEs. There's a lot of reasons to favor using build packs over a Docker file. Not least of which is you don't have to write a Docker file. You don't have to maintain a Docker file. You don't have to worry about everybody using the same things in their Docker files. So we'll just give this a second to keep working. In the meantime, though, I could probably show you, let's run another command here. So I'll make this a little bigger. Let's see. Let me get the workloads. Okay. There's this cool command, kubectl. There's it's a plugin called Tree that shows you all of the descendant, all of the resources that are spawned from any given resource. So we can see here that we created the workload as developers, and then Cartographer went and created a Flux Git repository resource for us specific to our application that noticed that Git operation succeeded. It noticed that there was a Git commit to build. And so then Cartographer took that information and created a cloud native, a KPAC image that is still working. So it's not ready yet. And when that's finished, we should see that the third resource come up that represents the running application. So I don't know why it's quite this slow. Let me see if there's any questions.
It's because you're doing a demo. If you weren't doing a demo, it would go fast.
It would be faster.
Yeah, clearly.
Yeah,
That's
this is the slowest that it's been in my working with this. Okay, so while that's happening, let's move on. I can do this another way. Okay, so we'll let that finish and we'll just improvise a little bit. So let me show you what I would have been showing you. Can I do that? Let's see. Yeah, this might work against me a little bit, but let me show you.
I just watched your IDE render. Did it render slowly for you as well? Or is
Oh,
it just
you know what? I wasn't really looking.
Oh, your IDE like clipped into view, and it was like a white square, and then the UI components started to render slowly thereafter, like it was loading its own colors and pixels and polygons and stuff. It was, I'm not sure if that was an artifact of Zoom or if your computer is just.
I didn't
taxed.
notice it.
Are you running Slack?
Yeah, everything is super slow. Oh, there we go. Okay. I didn't notice that, so I don't know. But
You are running Slack. That explains it. You should disable that. That'll make things go faster.
Really?
No.
Oh. I mean, I can do that. Okay, no more Slack. I feel like it's the streaming. It usually, like once, if it's Zoom, then how do you run these shortcuts in the terminal that runs the command for you? Oh, okay, I can show you that. All right, let's take a little side. So, so Dan is asking about this magic of like, I just press enter and then my demo command shows up here. So that is, a tool that one of my colleagues and I wrote called Demo Runner, which you are welcome to download. It's just a shell script that basically reads a list of commands that you've written. And there's some like special symbols to say, if you want things run without echoing to the screen or with echoing to the screen, or if you actually want something to just echo as a comment that doesn't actually run. And the way that you would write your script would look something like this. So there's an example file in there. And then you just run demo runner and you feed it that script. And then it does all those things. And if you really like this and you want to be part of this, there is a list of things that don't work yet here. So if you want to implement that and submit a pull request, then you would make this even better. But this is what we're using. This is what I'm using.
Cool.
Yeah. So, okay. So let me check again. I think this is, oh, okay. It's moving forward. Okay, good. That's a good sign. Okay. So in the meantime, let me just see if, why is this so slow? Okay, so let me show you. Okay, what's going to happen is that the image is going to finish building. And then, of course, we would see that image published to Harbor, which is not here yet, but we would see a new image show up here in Harbor. Oh, wait, it is here. Oh, interesting. Okay. All right. So let's go back here. So I wonder why this isn't. Okay, bear with me a little bit longer. I'm gonna
Debug time.
All right, sorry, Ben.
We should have a segment where we ask people to come and help us debug stuff.
Right? Yeah. Okay. So, oh, there we go. Okay, it's moving.
Come on.
Build successful. Okay. All right, it's finished. All right. So we saw that the image was built. Now, if we were to look at the tree again, actually, you would see that, yeah, I'm just a little concerned that everything is so slow. Now you see that this pod complete, it looks red, but it's actually okay. It finished the build. And now we see an extra line here that it created, it's actually an app that will then deploy the Knative service. So if we return here, as a developer, again, I'm using Tanzu Apps workload. I can get the information about it now that it's done. And I should be able to click on that and it should work. Let me just refresh that. I don't know why none of this is working right now. So it's deployed.
Revision.
The revision missing.
Revision missing.
But I don't, let's do this. So actually, Dan, since you're asking this tool to run demos, one nice thing about it is that you can actually just type other commands in there. So I wonder if it's just sort of a resource problem on my computer because none of this is working.
Probably. So, that happens.
Yeah. So you know what? Okay. So I'm going to give up on like the live demo, but I am going to show you one thing I wanted to show you. So I think what we have seen is that Cartographer is doing its job, right? Like it did find the Git commit, it did build the image, and it did try to deploy the Knative stuff. There must be some resource limitation on my machine. Maybe I should have rebooted before I did this. But what I wanted to show you is a little bit of like what is happening, what's the magic behind the scenes. And so I'll just explain that to you by showing you a few files.
Ben volunteers from the shadows that it might be, and I quote because I don't know, I don't purport to know what it means. It's probably just that the log tunnel is broken, which, take a shot if you understood.
CPU can stay and it's still spinning up the pod. Yeah. So maybe it'll still come through for us. But if this is slow, I think like everything I try to do is, okay. All right, so now it's just slow. Okay, but it works. So there's the app.
Yeah.
Okay, so, all right, let me try to do it the way that I was. Okay, we'll try this. And if it's too. So what I wanted to show is like, what happened, right? How is this even working? So now I'll go through a few files. So the cartographer catalog installed this default supply chain. But I think a good way to think about it is like, what if we didn't have cartographer? What would we have to do to get this workflow to work? And by paying attention to everything that we're doing manually, it's a way to like recognize where there's an opportunity for automation and to understand what is the automation that cartographer is doing for us. So that's how I'm going to approach this. So if I look at, if I know that I want my workload to move through Flux, right, so that I can detect code commits, through Kpack, so that I can build my source code into an image, and then to Knative serving, so that I can, serve it up, run it in a way that's sort of feature rich. Then I know, I need to first of all install those 3 products, and then I need to write the configuration for each of those 3 resources. So this is what, for example, the configuration would look like for the Flux resource, right? There's no cartographer in here, right? We're just saying API version is some Flux CD thing. The resource name is Git repository. And right now I'm hard coding it to point to a specific application, right? So this is not reusable across applications, and it's not sort of integrated with anything else. Once I do that, I would want to create my image. So then I would say, well, what's the Kpack configuration for an image that I need to create? And I'm not quite ready to submit this to Kubernetes because I don't actually know what the last Git commit is, right? So here's already a clue that we need some sort of integration between Flux and Kpack, right? We need to get whenever Flux notices that there's a Git commit, we have to get that last commit from it and give it to Kpack. And then after Kpack has finished building an image and publishing it to Harbor or to whatever registry you happen to be using, then we need to get that tag, the full address with the SHA, and provide it to Knative so that it can run the application. So again, another opportunity for automation. So we have to create these 3 resources for every application. We have to monitor the 3 resources. And when we see that any of these resources has produced new output, we have to take that output, update the YAML configuration for the following output in the chain, and resubmit that to Kubernetes. But the great thing is that all of this is running on Kubernetes. So this sort of choreographing process that runs on top can be very lightweight because Kubernetes is taking care of all of the lifecycle management, right? All of the execution. It's giving us a sort of a common management API across all of these. It's a common operating system for everything, right? As opposed to like an orchestration tool that would have to provide the execution environment for any one of these steps, or that would have to know how to even launch any one of these steps, right? Or manage the lifecycle. So having Kubernetes as a common system is a huge thing. Hi, Abel from Guayaquil. Welcome. So the only one of these resources that I can actually submit to Kubernetes is this one, right? This is the only one that's not waiting for input from something else. So if I go ahead and submit that, then I can monitor it, right? So I would monitor by looking at its status. Kubernetes maintains a status for resources. So if I look at the status, I can see that it's already picked up a URL. It's actually because of the way Flux works, which doesn't mean that all things that pull Git would work the same way, but Flux happens to download a tar GZ of the source code for that particular commit. Here's the commit ID, right? for that particular commit ID, and it stores it locally on the cluster. And it puts that information under this field called .status.artifact.url. So in reality, like this is all I need, and I can give that to KPAC. So this is, again, sort of what we need cartographer to do, right? Number one, create the resource. Number two, monitor it. Number three, pull out a specific value from it based on, where the appropriate value is. So then I could maybe more programmatically just pull out that .status.artifact.url, and then I would edit my YAML here, and literally this is, again, just notice all the manual stuff is what we want cartographer to do. Paste that in there, save it, and apply it, right? So at this point, we've created 2 resources that are specific to this application. And this is going to have to build an image as well. So this is going to take a little while, which we probably don't want to wait for. It'll probably be a little faster than the last one because it's a Go application, but it's still going to be, I think, a bit slow. So, oh no, actually this one was fast. Okay, who knows? And we can look at the logs. It should just spit out the logs. Yeah, okay, so this one finished really quickly. Anyway, but again, sort of like side note about how awesome build packs are. KPAC has noticed that this is a Go application. The last time it built a Java application, and now it's building a Go application. And everybody in the enterprise would be running, building images in the same way with all of these great features like a bill of materials and just sort of all this consistency and efficiency and security built in. So that's already done that. So then we would, in this case, because of the way that KPAC works, KPAC happens to put this value, the latest image with the SHA, under a field called .status.latestimage, right? That's particular to KPAC. But since we know that, then we can grab that value out of it. I'll just put it into an environment variable right now. And then I'm not going to run this, but just to show you that you could do that variable replacement into a Knative, into our Knative YAML. And so then, so this is the value we've just updated. And so then you could either, there's kind of 2 choices you have at this point. You could either do a kubectl apply and have your Knative application running right in the same cluster that you are, which is the default that's packaged with App Toolkit. Or you could say, actually, I just want to push this configuration to my ops repo, because then I want to deliver this to my prod cluster, my disaster recovery cluster, or whatever, some other testing cluster, my performance testing cluster. So both of those use cases are valid. It's just that the one that's included with the product is the simple one of deploying right where you are. So that's how it works. That's how it would work manually. So how does cartographer automate this? And so it uses a couple of things. Number one, it provides us with these resources called templates as a way to give cartographer control over the various resources that we want to create and monitor. So for example, I'm just going to look at we'll just focus on the Flux and the KPAC because it's the same pattern, so we don't have to look at 3 examples. But here's a templated version of the same thing we just saw. So if I look only at this section of the YAML, that's just copy paste from the FluxCD resource that I just ran. And I just stuck that under a field called template. And this can be arbitrary YAML. And so then the next thing, so basically here, what I'm telling cartographer is take whatever's under template and apply it to Kubernetes. So I'm giving cartographer control to create a resource for me, for my application. And then the other thing, so then once cartographer is in control of this resource, it can monitor it. So the other thing I have to tell it is, well, this is Flux, so this is the field that I care about. Flux is going to put something here, status artifact URL. So in essence, I am teaching cartographer to work with Flux. So cartographer as a tool doesn't require like plugins or integrations or anything, specific. You can just use cartographer and choose something from the ecosystem and put whatever, if you don't want to use Flux, if there's another tool you want to use, then put that arbitrary YAML for whatever you want here. Then just tell cartographer where it's going to get the value for the URL or the value for that revision. And these two, URL and revision, are the kinds of outputs that you would expect from a source, from source. So that's tied to this source code template, cluster source template. And in the case of the image, we have a different kind of template. It's called cluster image template. So you would expect that a cluster image template would give you an image. Of course, we don't know what the image is, but we can tell you that the path to get that value would be .status.latest image if you are using KPAC. So kind of the same thing, right? Just copy paste that arbitrary YAML for your resource under template, teach cartographer where to get the output that you want, and then just assign it, right? The kind of template that you want, so it matches the output that you expect. So this is how we give cartographer control to instantiate, to monitor, to extract output. And then you can see once we get the output from the source, we're going to have to insert it into the image. So here, using this templating syntax, we're also giving cartographer a way to inject the output from Flux as input to KPAC. So every time that there's a new value from Flux, it's going to update this value and submit that to the Kubernetes API. And so Kubernetes will detect that a resource has been changed, and so it will update the resource, right? As usual. So that's sort of the magic behind it. And so just the last couple of things is we have 3 resources, but we also have to tell cartographer, do Flux first, then do KPAC, then do Knative. And we also want to, be very specific about the output of Flux going to Knative. So for that, we use a supply chain where we have a list of resources. And here are our 3 resources: the source template, the image template, and this is for the Knative. We haven't really looked at that, but a template with no output. So we list those in order. So the order here is important. And for this second one, we're saying take the input to this one should be coming from the one before. So here we have, it's a type source, and it's called source provider. So you can see this is source provider. And same for the Knative. Knative says, I need output from an image type resource, and that image type is called image builder, and that refers to the one right here. So this is how we're chaining things together. And because you can have many supply chains for different paths to production for different types of application, this works well for web applications, but if you have a streaming application, you might want a different workflow. So there's also a selector on a chain that a developer can then, place a label on a workload, and it will get matched to the correct supply chain. So the last thing I'll show you is that everything that I've showed you so far has a hard-coded application URL in it. So it would work really well for that one app. So what we want to do is extract the information. And we saw this earlier, right? When we did the Tanzu workload create. We want to extract the information that is particular to any application, which is basically the URL and the branch. That's it. And then you can expose, you can give the developer the opportunity to set some other variables, but this is the most important part. And so then once you have that coming in through a workload type resource, then you can go back into your templates and parameterize them so that instead of hard coding these values, we're now getting them from, as you can see, it's a workload spec get URL. So we're saying workload spec, source get URL, that same path, right? So we're pulling those values in from the workload that's provided by the developer. And so now through this parameterization from workload parameters, now these templates are reusable across many different applications. And so I think, I was just going to kind of show you that in the example, how it matches to that, but I don't think that I'll just show you one more command and then I don't think this is worth the time. But if you look at this cartographer catalog that I mentioned, it includes a cluster. It's the same example we just saw. It includes a cluster source template called get repository, the cluster image template called image, a cluster template with a Knative configuration. That resource is called app. You have the supply chain here. And so that's everything. And then, our role-based access control is always key in configuration. So there is also role-based access control to control different access. But this is stuff that if you weren't using this out of the box example, these are the resources you would expect maybe like an application operator to create. And so the developer would only have to, as we saw earlier, just create a workload, and it would automatically go from source code to production. So I'm going to cut the demo there because I think it took long enough. So let's see. All right. I'm going to stop sharing my screen. I can figure out to remove that. And then, so Josh, should we Tanzu Players it?
Yeah.
Okay, I'm gonna put
Yeah.
that. Okay, so we're so excited to have you here. Ta-da!
Hey, everybody.
Ta-da! Oh, that's so good.
Yeah.
That's good. We did it.
Oh,
Hi, guy.
Hey, it's been almost 2 whole days since I've seen you after not seeing you for 2 years.
Too long. Well, so we live in the same, we're in the Bay Area broadly, so you're one of the few people I had the privilege of seeing, recently since the pandemic, but it was few and far between for other people,
Yeah.
thanks for your
Great job,
patience.
Cora, by the way.
No worries. No, it was great to see people using Tanzu. It means the last couple of years of my life have actually been worthwhile. It's great.
Right. Yeah, so we should let people know that, Ben has done many amazing things in his life. His current focus is technical lead for the Tanzu developer experience. So this, I guess this is the closest that we can get today with App Toolkit in the open source world, is having this like one command basically install and then immediately be able to deploy a workload.
Yeah, and I've been taking a lot of screenshots as you've been working, sending it to our teams to figure out ways to make it even simpler than the stuff you're already doing.
Oh, good. That's good, because even with version 0.10, there was probably like 8 commands that I cut out there, just in between, like configuring KPAC and providing your own supply chain.
Yeah.
So I'm excited to see what 0.30 will be with
Absolutely.
today. Yeah. So for those who don't know you, I wonder if you would take a moment to introduce yourself, but also maybe share a little bit about your career, how you got here, who you are, and whatever you want to
sure.
share. Okay, good.
Yeah, absolutely. So as Cora said, I am the technical lead of the Tanzu developer experience. And for people who knew me in the past, this would seem like an absolutely amazing title to have today, because I have forever been a Spring lifer. I started as one of the earliest possible employees at what was Interface 21 there, and eventually became Spring back in 2006. I, in fact, did my interview for the job at what was called the Spring Experience back in 2005 down in Miami. I knew instantly that, I'd sort of been working for, out of school for about 18 months. I was at a defense contractor, a job I could have had basically for the rest of my life. But as soon as I learned about Spring and met the Spring team, I was like, nope, we're out of here. I am going to go to a place that has no healthcare, no retirement plan, and didn't even have a cap table yet. A startup that did not offer me equity, and I still went. Like, looking back on it now, it worked out well, but it was not the best way to run your career, certainly.
Well, passion is good.
Yeah, indeed. Spent the first 2 years sort of on the road, 44 weeks, like sort of Josh level of on the road, and on the road on the weekends even. My apartment became a hotel that wasn't the place I spent most of my time in. There was a Holiday Inn in Chicago that I spent more than in my own apartment.
Wow.
But for many years working on sort of open source stuff inside of Spring, and we took some funding, opened an office over in the UK, spent a bit of my career working on OSGI and things like that I don't want to think about too much. Definitely a wrong turn there. But
I wasn't going to bring it up. You did.
But sort of every single month, every single week, really talking to application developers, like really understanding what our enterprise developers did. In 2013, while still maintaining my position on the Spring team, also took over responsibility for the Java experience on Cloud Foundry. So like sort of my first introduction to, okay, like I know how application developers write applications. What do they want out of running them, those things on these platforms like a PaaS? And so from 2013 until the end of 2020, I did that as my day job. And then at the end of 2020, I took this new role. Finally, after 16 years, 17 years, whatever that works out to, left the Spring team, like only in an org chart sense, like spiritually. I'm still part of the Spring team. They still invite me to things, so that's a good sign. To work on this, to say, hey, like, what do all of these software developers actually want out of a platform that's based on Kubernetes, with all of the great characteristics that Kubernetes brings to the table? And so that's my day to day. You've seen like the initial bit of the work that we're doing. We got lots and lots more planned. You know, we still, like, I have not forgotten what all of those application developers want, what they deserve when they're doing their work. So I want to make sure we bring it to them.
So when you were talking about all this traveling that you were doing, like what kinds of conversations were you having? What was your main objective in talking to all these different customers? So
my main objective was to pay my own salary. So I'd be lying if I didn't say the vast majority of it was core Spring. My compatriot, as one of the other technical leads on tap, Mark Fisher, one of the other earliest possible employees over at Spring, we sort of did some back of the napkin math, and we think over the course of 2 years between the two of us, we taught 10,000 people Spring, like individually face to face. So like we really helped bootstrap that thing. But like interspersed in there, like clearly like that is, you know, the primary stuff we did, but like there are coffee breaks. You stay a day later at the end, you talk to customers about, hey, you know, I've got this project that I'm working on. How can Spring help me there? When you did consulting engagements, it was very much that kind of thing. Hey, like Spring has all of these features. Help me understand the best way to do that. And then doing conferences basically every single weekend. I'll put in a plug for No Fluff Just Stuff here, which, you know, we did for years and years and years. You know, the same kind of thing, like, hey, here's some things that you've learned. Hey, you want to learn Spring security or something like that. It always ends up in conversations of, here's my problem. How do I solve that kind of stuff? Up into Cloud Foundry, it's like, hey, now I've got an app and I'm a competent Spring programmer. I know how to do this thing. How do I actually get this to be a highly available production system? How do I do that without requiring me to know all of my infrastructure? How do I get that, you know, sort of CF push kind of experience, but have a great outcome at the end?
Can we work backwards a little bit here? Because your experience in helping people build stuff that scales in production is not, of course, limited to just the last 2 years. It's extensive, and you just mentioned your 7-year plus stint working on the developer experience for Java developers on Cloud Foundry, and so there, I don't even know how you found the time. You worked on the Cloud Foundry Java client, not to mention the work that would eventually became build packs, as we know them, you know, in the Cloud Native Computing Foundation, and you helped, as a byproduct of the work you were doing for the Cloud Foundry Java client, you helped forge Reactor, right? You know, in the embers of that work, and so I saw a thread earlier this week that I thought was just particularly interesting, where somebody was asking about the same old question. You know, it's the same misguided but well-intentioned question, which is, does Loom kill reactive programming? Right? It's like, and I've always said, well, of course not, because there's 3 big benefits. You get resource efficiency, ease of, you know, reuse of the threads. You know, you get a cost-effective threading with reactive programming, but you also get ease of composition, and you get operators to support back pressure and that kind of thing. So there's 3 big benefits, of which Loom serves half of one. You know, and indeed it could contribute to that first benefit in the reactive sense. So.
Wait, Josh, before you, for those of us who are not familiar, can you give it?
Yeah. So Loom is this wonderful thing that's happening in the JRE that I think in Java 19, they're going to have a preview edition of it, where they're going to reintroduce, I should say, green threads. The idea that the software itself creates the scheduler that then moves your work across different threads. And this was actually, interestingly enough, in Java 1, and they took it out because it was a hard thing to get right, implementation wise, and then they delegated to operating system threads, right? So one Java lang thread equals one task in the kernel, right? And now they're going to go back to that because it's nice if you can create more concurrent things in your code logically, even if there aren't actually that many concurrent tasks in the kernel.
Wait, are you saying that the reactive model makes it possible to revisit that sort of ambition and actually get it to work now?
No, it's that reactive programming has all the reason one of the reasons you might embrace reactive programming is because it gives you a way to write code in such a way that the runtime can move work onto the CPU when it's needed there, and then quickly move it off. So you're never just sitting there waiting, checking your clock, waiting for something to happen. And that way the rest of the runtime, the rest of the system can use that thread. And the reason that's important is because threads fundamentally are expensive on the Jerry. You can't create a million billion of them. You have to, it's finite. There's only a few of them you can use. So if you're trying to solve the famous C10K problem, right? The 10,000 concurrent socket acceptings, I don't know, accepts, there you go, accepts. The famous 10,000 concurrent socket accepts problem, then you can't really do that just by creating a new thread per socket, right? And having input stream and output stream. So reactive programming gives you a way to accept and then jump off the thread, do some IO and then jump off the thread, do some, produce a response and then jump off the thread. So you're never just sitting there monopolizing or bogarting this thread in the runtime. Loom takes a different approach, which is it makes the cost of creating these threads much cheaper. It makes it so that you can logically create tens of thousands of threads. And that would seem to moot that first benefit of reactive programming. But it doesn't at all address these other two, which is ease of composition and the reliability operators. And I also think it's just not, threads are not a way to write concurrent code. They're not a very nice, elegant, safe, or even very mature relative to some of the other options choices. So I saw there's Ben here had a great response to this question. Just I think it was this week or maybe it was last week. I don't know. It was recently, and I just was hoping you could talk about that. I retweeted it and shared it loud and proud. It was great.
Yeah, absolutely. And to sort of put a little bit more context around it, this was a person who was, sort of a web developer, comfortable and, very familiar with using Tomcat, for example. And like everybody knows that Tomcat doesn't have this linear scaling ability. Like it comes out of the box, it'll accept 200 connections simultaneously. But if you want load, you're really starting to talk about, hey, should I have 500 connections or 1,000 connections? But there's an upper limit, and it's not sort of like the 64K sockets that an operating system can handle. It's likely in the 1 to 2 to 5,000 connection ratio, range. And that's like a tenth of what your operating system should be able to do. And they were complaining about this, saying, hey, Loom's going to give me this. And to some extent it will. But like the big problem that people like this are staring at is absolutely the problem with the servlet model. It's not actually with threads at all, because the servlet has this idea that for every connection that comes in, it has to be serviced by a thread. And as long as that connection is open, that thread is occupied. Threads cost a meg or more inside of the operating system. They have this horrible scale, inside the JVM, and they have this horrible scaling characteristic. So people have often looked to reactive programming to get started, but they say, holy cow, like I can handle, we used to do some experiments on like my 2015 Butterfly keyboard laptop. Like I can handle 30, 40, 50,000 simultaneous open connections just on a laptop with 16 gigs of RAM. It was no big deal using something like Spring Web Flux. But the problem there had almost nothing to do with the size of threads. It had to do with breaking that connection per thread kind of linkage, because it would do that and it would do it with 4 threads and be completely responsive. And so like, I think a lot of people come to it and then they say, hey, Loom is going to solve this for me by lightening the threads. And like maybe initially, maybe servlet behaves a little bit better than it used to. But fundamentally, like the people who really, love reactive programming actually love it for the silent F in it. It's actually reactive functional programming, right? It's this idea that instead of having imperative thing and shared data, hey, like do this thing to this data structure, and then the next line says do this thing to the next data structure. If you need 2 threads that need to both operate on this, you have to have some sort of semaphoring and stuff like that, some sort of locking to guarantee that nobody's contending simultaneously. The functional part of reactive functional programming says like there is no shared data anymore. You take within the context of your Lambda, right? Like you're going to modify this data and then you're going to pass it to the next Lambda. And maybe you do that in chunks so that it looks like, a stream, but you're, either behaving on one or a small number of these things as you go. And like, that's really the fundamental thing that makes functional programming what it is, why people love it, even if it's relatively hard to initially grok. But the thing then that like reactive and, Josh talks about the operators and stuff, the thing that I really loved about it is it really appealed to the bit of the programmer in me that said, I like a thing where I can describe all the things that have to happen sequentially. and then all the things that can happen in parallel with one another and how they need to join back in, and like write a recipe, right? Write a definition for sequentialism and parallelism, and then hand it to a system that is much, much smarter than me to figure out how to get the best possible performance. Does that mean we need to put it on 2 threads in some places and 1 thread in another? Does it mean we need to, sort of steal work from the later on to guarantee that I don't have to do a context switch and we'll just keep running it on this thread at the expense of something else? Who knows? Doesn't matter to me. I just told you how to get to the end of it and allow the system to do something better. And I think like that's fundamentally why reactive continues going, right? Even in the face of something like Loom, you end up with this thing where like, yeah, like maybe threads are lightweight, but you still have all that locking, all that concurrency. Every concurrency bug you've ever made in any of your programming in Java still exists, and you will still make it even in the face of Loom. Reactive programming comes at it from a completely different direction. It says there are no more concurrency bugs. And like that is the real value if you can get over the hurdle of getting started with it.
That's what is it that, so when you're talking about both like the functional programming where you're just kind of like defining these things could be parallel, these things have to be sequential, and then you run that on a system that will sort of like combine that, the JVM have to be changed in order to support that side of it?
Nope, not at all. As soon as, like, if you look at
It came after.
Really got into reactive programming at the earliest possible point, it was with RX Java, and it was in Java 7. Before we even had lambdas, people were writing anonymous inner classes inside of sort of operator functions to get this. It was the ugliest thing you ever saw. So really,
and Java 6 on Android, right?
Yeah, there you go.
Yeah.
And like really the only thing we wanted that sort of unlocked sort of reactive for a broader ecosystem was syntax sugar. We wanted inline lambdas, right? And as soon as you got that, and instead of having an entire class definition, you could put it one-liner, in a couple of curly braces. Like that was all it was. Nothing changed in the JVM. Like I think it's really telling. One of the things I pointed out is, hey, like we got all that without Loom, right? Like my 30 to 50,000 simultaneous connections didn't need Loom to do it, which sort of proves the point that like threads are fine. Right? Like, sure, it's always greater if those threads are lighter, and who knows what amazing things we'll be able to do with reactive programming with Loom as well. But you don't need a fundamental JVM change like that to get the performance that people are looking for.
And so, what is the history of Loom? I mean, I don't want to say anything that would bother anyone, but like, why, like, did they not recognize, I guess, why not combine the approaches? Like say, well, reactive is so effective, let's look at that, and then say the things we're trying to do, maybe do those on top of reactive.
Yeah. So Loom has an incredibly long history. Like as Josh says, like we actually had what Loom has eventually become, like, back in the mid 90s. But let's say like the modern invocation of it, I think, we saw the first time probably like 2012 or something like that. It's taken a while. And even the Java 19 is going to be like a preview of it before it will eventually make it into whatever the next LTS is, 21, I think maybe. So it's like 2 years even from there. But I think the key thing is like, I'm not going to sugarcoat it. Functional programming is not what almost anybody learned in school. It is a vastly different way of thinking about problems than sort of standard imperative programming. And if your goal is to maintain the status quo today, right? Like to say, hey, every line of Java I've ever written before will still continue to work. We just get some efficiency gains out of it. Then Loom is the perfect answer to something like that. It's no worse. It's also no better, right? Like, sorry, it's better in certain ways, but it's not fundamentally changing the status quo. Right. But the bugs that you have are the same concurrency bugs that you did your entire career. You sort of have a mental model for, how to find them, how to debug them, how to fix them going on. Yeah.
So there's
to go to something like reactive requires adopting functional programming. Yeah. Like people start saying things like Scala, stuff like that, and they really start freaking out.
Yeah, I mean, it is. I don't think I've really successfully made that mind shift into, like I've copy pasted stuff that Josh has done. Basically, that's my reactive programming. But it is.
That was your first mistake.
It worked. It worked.
Actually, it's probably fine. I copied it from Ben, so if you got it from me, it's.
And this is like, to put a plug in for the team, right? Like this is, everybody loves Spring. I think Spring has really hit this really, really well, where Spring is the only framework, as near as I can tell, where you can have reactive and non-reactive code coexisting together inside of the same code base in the code you wrote.
For GraphQL.
Or even you can write imperative code, like your old style code in like one of your web controllers, right? And the very first thing it does is it allows you to preserve your thing, and then it gets it onto a reactive stream on your behalf. You don't get 100% of the advantage of if you were writing the whole thing in reactive, but you get a lot of it, right? Like it breaks that connection per thread kind of thing. You get a little bit more thread safety. Like within your block of code, it's a little bit dangerous, but once it's out of your block of code, it's in a safe way, right? A safe place. So like, I think that's one of the reasons I love, continuing to do reactive programming in Java rather than going nuts and going all the way out to Haskell or something like that, is I think full-on functional programming, like as defined by academia, is effectively impossible. Reactive can get you 90% of the way to that without requiring you to learn a whole brand new language and like break your brain. And then Spring can get you maybe 70% of that 90%. Like you still get huge advantages, and you can elect when to subject yourself to the additional complexity of the other programming model when it makes the most sense for you.
Is it that it is inherently like less intuitive and more complex, or is it just that we're not used to it?
We're not used to it, right? Like if you went to a school where they had a really strong functional programming, or you go into like other, major sort of other than mainstream imperative code development kind of majors, like you see people doing this all the time, right? There are lots of other places where, like if you went into telecoms, right? Like you had learned about Erlang. That's all functional, right? Like, and everybody sort of gets along and they know what they're doing. But if you came through my major program where you learned C, C++, and then Java, like you're dead, right? Like it's just not what you were instructed in.
There are plenty of people that their first introduction to programming was like Lisp.
Yeah.
And they'd be right at home in this world. It's just it's a oddity of history that the community has been bifurcated along these paradigms, and it doesn't need to be. We can have both. Have our reactive cake and eat it too.
Yeah, I mean, it's still it is a thing, right? Like it's because functional programming has a longer history, right? And so it is a little bit of what you're used to, but I know I just haven't worked. I probably haven't worked with it enough, but it does, to me, trying to learn reactive programming in Java is extremely difficult. It's like I haven't found really a good way to wrap my head around it.
One of the best ways I heard it described is like imperatives to sort of traditional Java has a really gentle learning curve, but is asymptotic towards like the hard things to do. Like you eventually get out to the end and you have to be the best possible programmer on earth to achieve some of these really complex things in Java. Like take note, really highly concurrent systems where you do have to manage locking and threads. On the other hand, you end up with functional programming, which has this really steep initial learning curve that's asymptotic to flat, right? There is no level of complexity you can't attempt once you've gotten over that initial curve. And like they cross somewhere, right? But it's day one is like, do you invest now for the future, or is day one, do you sort of ramp up and potentially not be able to accomplish the thing, at the zenith of your career?
And I've always said that there's only one person who truly knows how to write multi-threaded Java programs, and it's not you. I don't know who it is, but it's not you. That's the point, right?
Brian guess probably.
No, but yeah, maybe. But with an asterisk. But remember, even Java itself had a bug in its reentrant. Was it double locking? Remember that before Java 5? There's a bug in the JDK itself with respect to double locking, and it's like it wasn't even correct. The spec said X and it did Y for years, and nobody even saw the bug. Right? It meant that it was unsuitable for certain classes of concurrent programs. It's just hard. I'm not saying it's not a slight on anybody. It's just really, really hard. Don't give yourself that pain if you can avoid it. Get home on time. Use reactive programming instead,
Oh, well, I'll give it another shot. Yes.
If I can do it, then definitely anybody can do it. That's the way to think about it. It just takes it is like those people talk about Lisp and they get that aha, that epiphany, that like moment when it all just clicks and you get it, that paradigmatic like shift. And I think reactive is the same. Like you said, there's that initial hump and then ta-da,
all of a sudden the matrix reveals itself. Right? Yeah.
Interesting. So that all that reactive work that you did was kind of in the middle, like of your time managing the Java build pack effort.
Yeah, like, I mean, for what it's worth, like it had a very specific reason, right? I've often said that nothing focuses your mind like being yelled at by your customers. And given the pricing of Cloud Foundry, we had customers yelling at us a lot.
Yeah.
And so, like, in lieu of changing pricing, which is not something an engineer really has a whole lot of things to do, a lot of it came down to, okay, so how do we make customers need fewer AIs, right? Like, how do we make each one of these more efficient? Because you look at the data and what you see is like they'd scale to 200 to 500 to 1,000, and like that was about all the memory could handle, you know, on one of these JVMs, or the number of concurrent connections, the number of threads they could get. And so they'd start horizontally scaling them and paying, you know, X for this one and X for this one and X for this one, and that'd be fine if it was justified. But these like CPU wise, these were running at about 35% efficiency. Right. And like, that's like, you all of a sudden start seeing there's this disconnect with the you know, sort of spike in cost versus the actual utilization of each one of these AIs. And so my entry to reactive was someone coming and saying, like the same as everybody else, hey, we can do this more resource efficiently. And you're like, now I get it. And now all of a sudden, like, we could collapse, like, we had customers regularly collapse 10 horizontally scaled AIs into a single one, realize that they'd given themselves a single point of failure and scale it to 3, not because they needed the load, but because they needed HA out of it, right? So like, that was definitely how I came to it, but like, I stayed for it, right?
Is that how you came to it, or is that how reactive came to Spring?
I have actually no idea how reactive came to Spring. Like, it was always a thing that we knew about, and we ended up, you know, poking about and hiring some people. And it was definitely like, once we realized, I mean, like the Spring team's smart, right? Like, once we realized what it meant, I think another thing that's really underappreciated about reactive is, you know, depending on your framework, this isn't like inherent to reactive, but the way these frameworks are written, because you're passing data through steps, right? There is no shared data. Errors become a first-class thing that moves from one end to the other, and most importantly, requires you to handle an error at the end. There are no just sort of random percolated all the way up to the top errors that happen, right? Like null pointer exceptions or something like that. That's not a thing, because the very last thing that anything has to do is say, hey, like, in the case of success, do this. In the case of error, do this other thing, right? And I think like people miss out. Like we often talk about, you know, the idea that efficiency, again, is like a thing most people think about, but you stay for the safety of the whole thing. I think Kotlin, like, one of the things I've always loved Kotlin as a language is it has the same characteristic that something like reactive programming does, and even Java itself had. Like, Java looked at C and C++, looked at all of these buffer overflow errors and said, you know what, our language is not going to allow buffer overflows, right? That's just not a thing that will ever happen here anymore. And from that perspective, it's always been safe. Think of the bad years of Microsoft where they were just fixing buffer overflows every single day. One of the things I love about Kotlin's, and I think Java kind of stagnated there. It never attempted to solve the next most common error, which I think we'd all say is probably null pointer exception. And you take a look at Kotlin, and Kotlin's, you know, sort of optional behavior means you can never get a null pointer exception unless you really work hard to do it. Like, we sort of override the safety of the language. And like, that same kind of thing is what reactive does. It says you can never allow just an unhandled error. That's not a thing that we do here. We're going to eliminate that and force you to handle every single one of these errors that could ever possibly come into the system. And it's all about that. Like, when I look at what attracts me about programming models, or what attracts me about programming languages, it always comes down to, every single time, can you eliminate an entire class of common things that people do wrong while still allowing them the same flexibility they wanted before?
Which, I mean, that sounds like the perfect mindset to be responsible for build packs, right? Because you're
yeah, absolutely.
Right?
Yeah.
So I guess because you worked, like, what were the major, when you think about build packs, what do you think were like really the major, I guess, innovations, or like the major categories of things that you found? Like, were there any things that like surprised you or really pleased you about ways that you found to deal with Java applications in a more structured, automated way?
Yeah, so like one of the things that have always attracted me about build packs, both the ones that I write and the ones that like customers might want to write, is this idea of leverage. So Java is a language that clearly predates running inside of a container. It's a language where on the space versus time scale, it went for space every single time. So like one of the things that people probably don't realize is once the JIT inside of a JVM really gets warmed up, it's faster than optimized C code for a lot of things because it has the ability to watch real-time data flowing through. And so when it comes to like branch prediction and its optimization, it says like 99% of the time we're going this direction through the branch. I'm just going to optimize the hell out of this. Way more than like a static optimization of something like C or C++ can do. So like it can be fast, but you know how it does that? It reserves 240 megs of memory for JIT compiled stuff, right? Like this huge, massive amount of memory. Clearly, long before something like containers was coming into play, it was 64 terabytes of memory on some mainframe somewhere is really what it's looking for. There are like a number of things, like for example, its DNS implementation still doesn't know TTL because their DNS implementation happened before TTL was a thing in the DNS spec, or it doesn't use OpenSSL because Java started 6 months before OpenSSL started. Like it's this ancient thing, and so like cramming it into a container is not something that your average Java developer will ever be able to know, right? Like they'll never get it right. Maybe they can cargo cult some, flags, but like the very first thing we would do when we went to consults with people is we'd say, okay, take all those flags, just delete them. I'll bet you it behaves exactly the same way. Like nobody knows what any of these flags say. and like remarkably, that was a very common thing. So one of the things that struck me is I was forced to learn, as someone responsible for Java on Cloud Foundry, what it takes to get a JVM to behave nicely inside of a container, right? Like I had to really deeply understand what the memory model is. And everybody thinks like there are all these dynamic parts of the memory model inside of the JVM. And it turns out 5 of the 6 of them can be predicted relatively easily before you actually start your application. And even if you couldn't predict them, they're completely static. Regardless of the size of the heap or how long the application's running, they always stay exactly the same. And like, who has to learn that? Like I had to learn that, but there's this huge amount of leverage because we ran like, sort of I trade stories with my Heroku counterpart, the person who was responsible for Java over there. And we think like over time, we've run 1 billion Java processes or something across these 2 platforms. And like he and I had to learn this. That's an incredible amount of leverage. And what's always struck me about build packs is you can take someone who can become an expert in a thing and like just move that to everybody else in the ecosystem, whether it's me learning that or it's the New Relic people saying the way you should attach New Relic to a Java app or a Python app or something like that is exactly this way. Sure, we gave you a lot of optionality, but we're the experts. Trust us when we tell you to do it this way. Or even better than trust us when we tell you, we're just going to do it for you because it's the right way. And like that, we saw that same thing as we started looking off towards Kubernetes. I was working on that even before I took this job on Tanzu, is like that's missing with Docker files. Sure, your company can put together, a bunch of pipelines and golden things and stuff like that. But in the end, you'd never even get beyond the scale of leverage of here is your company, the way your company does it. You don't ever get that. And here is the broader ecosystem. What if my Java knowledge could be brought to every single Java workload on any Kubernetes cluster anywhere, not just inside my own company?
In the way that Spring Boot's auto configuration lets you pair program with the Spring team, build packs kind of let you pair program with the ops team, right? The leaders at running Java at scale.
Yeah,
that's fascinating. I mean, I feel like it's there's so many ways, there's so many things that one can say to communicate the value of build packs. But it's interesting to like. I think it's very like you're saying, right? Like you and your counterpart at Heroku had to basically probably almost reverse engineer the JVM to like really understand it. And
I've seen some things inside that code base, man.
But to hear that aspect from you, because I've done a lot of work sort of just sharing the goodness of build packs. And so I've been sometimes I look through like the output of a build process and I'm like, oh, this thing is mentioning this thing. Is that something to point out? And so I've gotten a few, pointers over time about like, well, mention these, but it's very surface level, right? Like to hear you actually saying like this very deep knowledge of all the memory management and exactly how you went about all these this idea, right, that the JVM was not built to run inside of a small container, and the depth to which you had to go to make it do so well. Like it's good to know that I haven't been able to communicate, I guess, that in sharing about build packs because
and like it's easy to talk about that with sort of my context on the Spring team. Like I was like, you want to pair program with the Spring team and Spring Boot, you were like looking at the Spring team's operational expertise around Spring as well. That's sort of what I was doing. But like take a step further than that. You take a look at the way Cloud Native Build Packs does, right? Like that was my expertise come to Java. And then we could take the same kind of expertise come to images at all. And so when you see things like very, very strictly layered images so that you get a lot more reuse between things, always making sure that there is a software bill of materials. I mean, like the Java software bill of materials coming out of Cloud Native Build Packs has been there for 2.5 years, basically from the very first line of code that I wrote. And like, so now we talk about it, and it turns out all of you have had software bill of materials this whole time, right?
Yeah.
Something that we knew you wanted to do even if you weren't ready for it yet. And like that gets to it. Like, as I've gotten older and older in my career, like I used to point at actual lines of code that I wrote, and now it's like systemic changes in the industry are much more important. Going back to like, how do you eliminate entire classes of things? How do you give entire classes of best practices to the entire industry?
Right. I mean, right. And there must be some like balance of like, if you're responsible for a particular implementation of build packs, to try to make sure that some of these best practices are fed back into the project, I guess, so that they can be adopted by other implementations.
Yep. Yeah, absolutely. And so that's it. Like the very first versions of the software bill of materials were like, you used to have a whiteboard effectively in a label, and you could just cram anything you wanted into it. So we crammed all our SBOM into it. And then like you take a look over at like the Heroku folks, and they looked at theirs and like, oh, that SBOM is like kind of a thing. And in fact, Bloomberg did the same thing, and Google looked at it, saw the same thing. Fast forward to today, and I didn't go to this week's meeting, I apologize, but like SBOMs are totally a thing inside of it now. They're not only are SBOMs a thing, they're in multiple different variants. If you're using SPDX or CycloneDX or something like that, they're all available as a first-class construct. Every Cloud Native build pack build, image build, regardless of whose build pack you use, has the ability in a first-class location where a software bill of materials will show up. Something that like Docker just announced, like here's a way we're going to get these things on here, but like that's sort of very new. It's not like in a well-known standardized location that you can expect to find in a bunch of different implementations.
Yeah. So I was going to ask, like, what I have two questions for you. One part of my head wants to dive into this, like, what do you see for the future of Dockerfile? And then the other part of my head wants to go to Tanzu developer experience. But so let's do what's your view of the future of Dockerfile?
Yeah, like we'll try and tidy that one up quickly. I think in the early days, I was really optimistic about the downfall of Dockerfile, but then I realized like it serves a really important part in the ecosystem. There are things for which build packs are not a good idea. Like build packs favor homogeneity, let's say. Like what they want to do is you to have an input and us to shrink it down into the exact same box for everybody. Like if you give me a Java app, we're going to like always put the JVM on in exactly the same way. If you give me a Python app, we're going to make sure that the Python app goes the same way. And that's not the truth for certain applications, right? Like there is a theoretical possibility that you could package up Postgres using a build pack, but by the time you wrote a custom enough build pack to do it, you should have just written a Docker file to get that done, right? So I think that where the future goes is really understanding whether your app fits in the box or whether it can never fit in the box. And then like that middle ground where it might fit in the box with some of my changes, gets me there and gets me all of these other advantages. Like we didn't even talk about rebasing, the possibility that you can like pull out all of your vulnerable operating system packages and put a new operating system under an image without transferring any data, right? Like, and you can do it in a couple of milliseconds. Like, boy, wouldn't you like to have that than whatever your current system is that's, you know, recompiling Postgres and stuff like that. So I think like they end up living together. I hope that more and more apps move up to these higher and higher layers of abstraction. Like Java had this, you know, sort of really privileged position where we never called out to the operating system, so the operating system didn't really matter. So we could like move into these smaller boxes. If you're, you know, a C++ developer, or you're, you know, something like that, like you could never do that kind of thing. Like, or it was much harder to get into the box. But I hope we start seeing more and more people say, hey, like I'm writing a web app, right? I'm going to use this box here because of all the advantages and all the safety and all the features that it gives me. And maybe my stuff doesn't work there, and so I need to fall back to a Docker file. But Docker file is going to, you know, exist forever, and for good reason.
For good reason.
We could have ended it. We're nearing some sort of place where I would have liked a high note, and instead you just.
I used to say Docker image yes, Docker file no. I'm a little bit calmer than that these days. I still think it's true, but again, like I have a privilege. I work, you know, way up at these really high levels of abstraction where it really is, you know, works well for me. And I think I'm just a little bit more realistic than I would have been, you know, 5 years ago. So
I guess like I feel like build packs should be. It would be nice if build packs were well known enough in the community that when people reach for the easiest thing, they actually go to the easiest thing. Because for people who are familiar with Dockerfile is the easiest thing. But if they knew build packs, they would realize that build packs are actually easier for many cases. And so just being aware of both would just empower you to choose what's actually easier.
Well, and plus, easy doesn't necessarily mean good, right? Like it.
In this
easy to drive.
Yeah. Well, I mean, in the sense of making the easy thing the right thing, making the right thing.
Yeah.
Sorry.
Docker files aren't a good Docker file is not an easy thing to write at all, right? It's gonna be long, and like you can drive a car really quickly straight into a wall at speed. You know, it's easy.
That's a good analogy for your average Docker file. Absolutely.
Yeah.
Because we talk about just like the joke always was the one sliver of the build pack that delivers the JVM and nothing else. Like if you were to replicate the behavior that it does for every single person who uses that, you'd need to write 64 lines of Docker file to get it right, to make sure everything was permissioned right, to make sure you've done it on, I totally even lost the phrasing, like on the build image before you pulled it into the final image at the end, right? Or multi-something image.
Build step, whatever.
Multi-stage.
Yeah. Multi-stage, thank you. Multi-stage build. Like you have to do all of this stuff to get something that is truly as safe and truly as isolated on a given layer as the thing that's the stuff that we're doing. And maybe for some people, like, who cares, right? But we think like bringing that to everybody, as you say, Cora, like it'd be great if it was the default thing that people started with and then fell back instead. I'll put in the plug, Cloud Native Build Packs, CNCF open source project. If you go to buildpacks.io, it'll point you to when our working group and public meetings are. Paketo Build Packs, which is a CFF project at the moment. Again, public open source project. You can go to their website and there's lots of meetings to join in there.
Is it paketo.io also?
Yeah.
Yeah, I'll put both of those in here. Paketo.io. So they're amazing. So all right, so turning to, I guess, your current focus, which is the Tanzu developer experience. Like, what are you most excited about when you think about, I guess, Kubernetes developer experience ultimately, right?
Yeah. So I think.
Wait, so just before, is your thesis that the developer experience in Kubernetes is not already perfect?
Yes, my thesis is that the Kubernetes experience is not perfect. And like, it's an interesting thing. Like, what tempts a 17-year veteran of the Spring team, someone who was there right at the beginning, to say, I can do something good, right? I think especially like Mark and me both leaving at roughly the same time, again, leaving in quotes like organizationally, we still have a lot of fun with the Spring team and lots of talks with them. And like, I looked over at it and I saw the same thing that the Spring team told me they saw, right? They saw this, huge opportunity where developers were being handed way too much complexity. Like they were looking, Rod was looking at EJB too at the time, right? Like, and all the different bean types.
Take a shot.
And, yeah, and like I looked over at the Kubernetes world and said, like, not only do I know the play here, right? Like I know what developers want, I know what they need to be subjected to. I understand the idea of how we can start building up layers of abstraction. I understand the idea, like we use it in marketing terms, we call it an app-aware platform. So platform understands your application. But for those of you who come from the Spring community, what we're talking about is dependency injection and inversion of control. Like I know this plan, and yet, like, as amazingly large as the VMware developer, as the Spring and Java developer ecosystem is, I look over at even bigger, right? I see an even bigger group of people who are being handled the same crap sandwich that Java developers were being given 20 years ago. And I can help them. Not only can I help all those Java developers when they run their stuff, I can help Python developers, I can help Ruby developers if there are any left, I can help, ML developers, I can help, web developers, I can help all of these people by bringing those same kinds of developer advantages. And that's what really tempted me away and what I really look forward to every day.
Wow, that's inspiring.
What is the concrete manifestation?
We are hiring
these days. Oh yeah.
What is the concrete manifestation of that? So
2 years on.
Yeah, 2 years on. So Cora showed sort of the open source core of what we do.
Yeah.
I perhaps am a little bit embarrassed to say that most of what she showed is most of what we do. We are very, very strongly committed to doing a lot of work in the open source, right? Like every major component of our system is an open source project or is open source code that everybody has access to. So when you take a look at what you can run in TCE and in the pure open source, we're not neutering it. You don't end up with a worse experience than you'd get if you would pay us. Like, again, what are Spring sensibilities? If a programmer touches it, it's open source. We'll figure out another way to commercialize it on the other side of it. We'll say, hey, like, your enterprise needs to, integrate with name enterprise security scanning company. We'll make sure that they pay for that. Hey, you need this, integration with Active Directory for identity on your platform. Yeah, we'll make somebody pay for that kind of thing. So I think like our concrete manifestation is that like there is a path today to give me source. I'll give you a URL at the end of it. It is different, right? Like this is not an imperative CF push kind of thing. We really strongly endorse the idea of both you start in Git and you do a lot of Git pushing and the platform just sort of pulls through. Like you, all of a sudden you start seeing the, like when your brain flips over to reactive as a programmer, you start seeing it everywhere, right? The idea of, all of that supply chain stuff you showed with Cartographer, Cora, like is effectively a thing at the end, a Knative at the end, pulling, requesting more data at all time. And every once in a while, there's a supplier that's your Git repository that says, hey, here's a new thing to pass through this chain, right? Pass through the stream all the way to the other end. So I think we're delivering on that today. There's huge amounts more work to do. Like I want the actual experience of users to be even better than you're looking at today. I want to be able to plug in a whole lot more things. Like we look at the secure software supply chain. We were certainly saying it internally long before it became the brand that it is today. But like, it's not enough to simply have, like source build, kube config, URL running at the end. We need to inject into there all of your signing infrastructure, all the verification infrastructure when you run. We need to make sure that we're doing, like image scanning based on, like the software bill of materials. Is this thing that's passing through towards prod right now vulnerable today? And then, if it's not, then we'll let it go to there. But then also the backside of that functionality, like new CVEs come out for running code every day. How do we help you find out? Like, boom, log for shell comes out. Is that what it's called? Yeah, log for shell comes out. Here are the 17% of your applications that are currently vulnerable to it because we watch the bill of materials go by. We can notify that to you. I really also like what the Backstage project is doing. Like I could talk about Backstage forever. We're basing our developer GUI on it. But one of the things that really struck me about Backstage is, getting back to like let's solve fundamental problems, is Backstage, while it'll show you like the health of your pods or the health of your VMs or something like that, like that's not how it became famous. It's not the actual most valuable thing that most people, most developers, most organizations actually get out of it. It's the recognition by the Spotify team that a developer, most of their day, learns things and wants to learn things. And maybe that's learn things in the sense they're going to go look up an API, but it's also learns things like what services are available to me. If I chose a service and something's wrong for it, where do I open an issue? What Slack channel do I go to for support? Like we talk about, certain things like the Tanzu Learning Center, TLC, and like, hey, wouldn't it be nice if you needed to learn, if I'm the account service team and you want to learn how to do it, I can actually pop up like an entire environment inside of it. You can learn how to code against my thing. And like all of that learning, like that's the stuff developers do. And like, yeah, okay, I've got to make sure my pods are healthy. But these days, you get an SRE team that helps you do that. Kubernetes is really good about keeping things healthy. In a lot of cases, it becomes less and less of a burden to keep things healthy, but the burden of actually learning never goes away. And I think like that is what really twigged on me for Backstage as well.
Interesting. Josh, have you played with Backstage yet?
No, I can't say I have. I was just looking at the website, backstage.io. Looks good.
We should show you some of the instances we have internally. Like it's amazing to think like Backstage is clear. Like, it comes from Spotify. It was clearly oriented towards an organization that was running services and stuff like that. Like realistically inside of the Tanzu application platform project, like we don't run services. Like we're building software that you're going to install for you. And yet there was no single person that could tell me every single team, every single component that goes into Tanzu, right? And so like we spun one of these up and all of a sudden we got, the very famous services map that like Netflix once did, right? The Death Star. Yeah. It turns out we got a Death Star too, and nobody knew it until we put it all into Backstage. We're a single team, where all of the teams come together and like, oh, hey, look, here was that thing that was duplicated over there. We shouldn't both be doing this. Let's figure out how to reconcile something like that.
That's cool. Yeah, somebody I'm blanking on his name, but who was it? Chris something did a demo of Backstage on Tanzu Tuesdays a while back, maybe a few months back. And that
Chris Applegate probably, one of our TLs. Yeah. Exactly.
And so when he showed that screen of like the map of your microservice architecture, that like having I guess, I've gone through a career where I've done consulting and I've done pre-sales. And so there's been a lot of conversations with customers about like, okay, let's draw out, we'll have a little interview kind of, and we'll draw out what your application actually looks like and what are the arrows and this, there was just like all presented and it was just so powerful. All these things that take so many conversations and so much collaboration are suddenly just sort of like brought to light by the tool.
Yeah.
Pretty powerful.
Amazing.
So I'm thinking we could switch over to our evolution or revolution. And I guess, okay, I'm just going to do the little evolution or revolution. Yes.
We need the echo.
I know. We need to do the audio. Yeah, exactly. Yeah, that's exactly what it looks like. So, there's so many things I feel like we could explore. As you were talking before, one of them, like Josh and I before, we were kind of like, well, if Ben's here, we could talk about build packs, we could talk about Kubernetes in general. As you were talking before, I was wondering about like reactive. So the heart of this segment is to pick something and then really, figure out if it's an evolution or a revolution. So I guess either Josh or Ben. So those are the three things in my head, like build packs or reactive, or as you said, maybe something more general to Kubernetes. But do either of you have a more like, I want to talk about this or something else?
Is it fair to qualify like it's revolutionary within the context of X? Like it's not, because I'm of the there's nothing new under the sun, right? Like everything we talk about these days, it's not like we didn't have a way to do computers to deploy to computers 30 years ago. It's not like that didn't happen. It just wasn't as fast and
it's your show, Josh. You can qualify it however you want. But one of the
as a guest, can I pick the topic? Because I've got one that's not on the list, but is very top of mind for me.
YAML.
About, yeah, YAML. Is regressionary? SaaS services. How
Which
about that?
services?
SaaS services, software as a service.
Oh.
Services. Yeah. Like when we take a look and we start seeing a bunch of things and like maybe SaaS, you start maybe knowing about the idea of SaaS because you're a New Relic fan, right? And you have an APM that is now completely a SaaS. And then maybe you start taking a look at AWS and, AWS has a whole bunch of stuff that's SaaS, or you take a look at this particular security vendor that's a SaaS. And then eventually you start looking at entire platforms that are SaaS.
Mm-hmm.
And do you think that that is a revolution? People who used to run all of their code on-prem and now are being asked to run a lot of it in the cloud, or an evolution of what people care about and value?
So it's a great question, and I'll just say before we to tie what you're asking together with what Josh said about like, is anything really not coming from something before, right? In some sense, everything is a little bit of an evolution, but something Matt said. So last episode we were talking about like Hadoop, HDFS, which I think I was not differentiating between them properly, as I realized after the episode. But anyway, the point was, one of the things that Matt said about why Hadoop was revolutionary had to do with like how Google made it adoptable by the masses. So which I thought was really interesting, because there's a concept of whether an idea in and of itself is revolutionary, or the impact that you can have with it because you did something different in the way that you make it accessible or adoptable or whatever. So I think that probably somewhat applies to SaaS services, because there's, there was if you think about email as a SaaS service, like we've had that for decades. And then some companies have put more things on SaaS and done some things better that actually have an effect. The secondary effect is revolutionary. So yeah, Josh.
Salesforce. So the first, you're right. I didn't think about email. You're right. That's actually a great example of a online hosted thing that we've all consumed without any issues. And we've never like, why isn't this in my data center? I don't care. I used, Hotmail 30 years ago, whatever. But no, Salesforce to me was the first big SaaS. I remember companies you had to have CRMs and ERP systems installed. Sable and Siemens and all these companies had these giant things that required golf games and thousands of consultants, to get working. And suddenly it's like, no, I'll just sign up for an account and I'll have my own CRM. And as long as my credit card doesn't run out of money, I'm in business. That was, I think, revolutionary. I would say that was that context.
Mm-hmm.
When I hear you describe that, actually, what I hear you describing is an evolution in software and a revolution in finance, effectively.
Yeah.
The freedom for you to just use a credit card to buy into this thing without the golf game. For me, one of the most, as I hear all of people talking about, how they get to, why after a decade, 2 decades of people being really resistant, hey, it's my data, I can't let it out of my data center, and those same people, it's one of the bizarre things about working in basically the same industry forever, with Spring people forever, is a bunch of the people I trained 20 years ago when they were just MTSs are now vice presidents making decisions at the banks. And so we end up seeing each other oh, hey, I remember your face. And these are the same people who flipped around and now they're SaaS only, we won't do anything else. And that switch on their balance sheet between CapEx and OpEx has been a revolutionary change in finance for them. It means there's no longer any depreciation. They don't have to sign these real long upfront contracts that are enormous. Instead, now they know and they can keep an eye on exactly what their consumption is. It comes out of a different part of the way they report their earnings and stuff like that. And that's been a real thing. And so we say SaaS, we often say SaaS and subscription at the same time because they go together even though they're separable. But that's what I hear is that we are on an evolution of software and a revolution of finance that comes along with it.
Well, even the software, if you, again, the self-service, take my credit card, give me something in return, AWS, right?
AWS, right. Where's the line between IaaS and SaaS?
Well, but I mean, in that I can go to their website and get a server on demand.
SaaS.
Maybe that's what we're talking about here. It's like Salesforce is on demand CRM as opposed to we'll set up an appointment next month and give you a consultation. We'll have it set up by Q4 5 years from now. Like assuming the golf games go well in our favor.
But I guess, well, I mean, when we talk about SaaS in general, we're not saying SaaS today, like some new service SaaS today. Like we could pose the question as like, let's go back to the first SaaS ever. Like what was that first SaaS ever?
Gopher.
For me, the big
Archie.
Gopher. Oh yeah.
Gopher.
Yeah.
Wait, what was
Possibly older than Cora, unfortunately.
No, I'm not that young. I just have a bad memory. And so what?
Google.
Yeah. So what was the impact?
Okay, so if I Google, and you can't lie on the internet, right? It's impossible. So if you Google it, I literally just Googled what is the first SaaS company. Question no question mark. I'm lying to you. There's no question mark. Are we on the internet? That didn't happen. Oh, paradox. What is the first SaaS company? The answer comes back from Google, and again, they can't lie. It's Salesforce, right? In 1999, Salesforce launched their CRM platform. Blah blah blah. I think hosted network services aren't the same as SaaS because it's not software, it's a network service.
There's a different acronym for it.
It's a Rorschach, right? Like SaaS is what you want it to be.
Right.
Certainly that's how my sales team thinks about it.
Yeah.
Right.
I mean, I guess one difference between SaaS and like IaaS is that SaaS is the kind of thing where like you don't need to know how it works in the background. Like,
yeah.
I like that I can search my Gmail. I don't need to know what they're running.
I mean, for what it's worth, I have no idea how EC2 works. Like I only lightly know that it's based on Zen and some
That's true.
virtualization.
But you got to put it together with other stuff to make it do anything. Yeah. But yeah. I mean, I would still I think there's a way to say it's revolutionary.
Yeah.
To your previous guest, it certainly has unlocked revolutionary outcomes, even if it in itself is not revolutionary.
Right.
Yeah.
Yeah.
Google Maps.
Every company that I guess approaches SaaS more is really revolutionizing itself. I guess the changes that they're making to themselves are fundamental.
I liked what we did with Cloud Foundry, where you've got sort of the best of both worlds. You had a SaaS-like delivery, distribution mechanism, in that it was sort of it was on demand, and you could get updates quickly, and it was you didn't have the on-prem burden, but it's still on-prem if you wanted it to be, right?
One of the things that we grapple with a lot, like right now inside of Tanzu, as we start talking about future products that are coming and things like that, is this idea that SaaS is very relative to the user, right?
Yeah.
Cloud Foundry was observed as a SaaS. Like, let's also be clear, SaaS can happen on-prem, right? Like your developers consume Cloud Foundry as a service. And to them, it was absolutely a SaaS, while for the operators, it was not that. And go back in the other direction, like that analog holds for us. Salesforce is absolutely a SaaS, and there are an army of people that sit behind it who do not think that it's a SaaS.
Right.
Yeah, it's the wizard behind
exactly
the machine, the little wizard.
That's true. Who wears the pager, I guess, is the question.
Exactly.
If your org wears the pager, it's not SaaS.
Because and like we think about that, right? When it comes time to start slicing and dicing our customer base and the products that we're going to make, you can make a thing that looks like a SaaS for operators, right? That's a thing, right? That's TMC in our case. But no one would think that that's a SaaS for developers as well. They run a kubectl all the time. That's not what they're looking for. At the same time, you can look at something like Azure Spring Cloud, which is very much a SaaS for application developers, right? And so really understanding who that market is and what actually constitutes SaaS for each one of those is something that I think keeps me up quite a lot at the moment.
So what would be would you call it? How do you answer your own question?
Exactly that. I think SaaS is evolutionary. I think you can absolutely draw a line for sort of how we became more and more comfortable with more and more running somewhere else from me. And specifically, I think it's driven by an evolution of our customers. Customers have become less and less tolerant of operating their own software. And that's my thing, right? Like no one in the old days, like, you know, early days, you and me on the internet, like we might have run our own email server, but no one will run their own email server, right? There's like 7 real email servers in the entire world at this point. And for a long time, customers demanded that they run their own infrastructure, and then they realized exactly what that was costing them. And like, to link back to, you know, 30 minutes ago, like how do you gain leverage, right? Can you have Google or Amazon or Microsoft carry the pager for you? You know, if you're one of these, you know, Fortune 500 company, cool, we'll go ahead and do that. And like there's this evolutionary dwindling of what companies are willing to carry the pager for and operate on their own. And like there was like a step change somewhere, call it like 2 or 3 years ago, where all of a sudden like that thing is narrowing very carefully or very strongly now. And I think that's the explosion of SaaS that you see. Almost everything you want to do is better served by someone else carrying the pager and you being one of a number of customers that they are responsible for. Like I always marveled at the idea that companies wanted to maintain all of their own stuff in their own data centers because they believed that they could keep it more secure than Google could for them. Or let's not even use Google, let's just go with Amazon here, right? And like, it requires a level of hubris to think that you are investing enough to keep your stuff safe just for you. And if something went bad, like that was bad for you, right? But like, you know, your company would probably survive something like that. Whereas if something goes wrong on Amazon, like, it's a vulnerability that the entire internet, effectively, like, you know, certainly the Western world's internet is immediately subject to. They are much more incentivized than your operations team to keep AWS secure because they have hundreds of thousands of customers that they have to keep safe. And like, I think there is this dawning, like I said, like there's clearly been a step change where people realize, oh yeah, actually that scale where we're just, you know, a fish in the pond rather than the pond itself is super valuable.
Yeah.
Well, I think that says it.
Good turning point.
That's perfect.
Should we call it a night?
Could do. The night's actually arriving for me, and that's, I think, a sign. I need to go scare criminals, you know, instill fear into the heart of criminals as Starbucks man.
Save the world.
Hey, no, it's Cinco de Mayo, so I was gonna toast y'all, but
Oh, cheers! I have nothing to toast you with, but.
Josh, I heard you say earlier that it's Cinco de Mayo, but they don't. It's not in Mexico. No, it's the Cinco de Mayo everywhere in the world today. It is absolutely the 5th of May everywhere.
Fair point. Touche, sir. No, but it's the holiday, the ridiculous holiday. It's not as big a thing, but it's like St. Patty's Day. It's, you know, we enjoy it. It's okay. It's a holiday for us. You know, that's fine. It's okay.
Any reason to celebrate is a good reason.
Yeah, and I shipped some software to celebrate. This is called a Black Dahlia. It's a cocktail, tequila and cassis. Well, yeah, it was. Anyway, if you get a chance, a Black Dahlia, go find the recipe, my friends. You'll find it. It's delicious.
It's a good name. Ben, thank you so much. This was fascinating and just a pleasure. I had a lot of fun. I hope you did.
Yeah, no, thank you for having me. This has been a great opportunity to discuss all of the things that I love talking about.
Awesome.
Thanks, Ben.
Yeah, thanks so much. And I'm gonna sign us off with I'm gonna do this right. Deshaun normally does this on a little bit, but okay, I'm gonna sign us off with some music and
bye everybody.
Thank you.
Trying to tell